Alright, hello. So in this video, we're gonna talk about testing. I'm gonna give you a big demonstration of what Playwright can do. So just a quick refresher, we're running a Django application and it looks like this. It is yet another to-do app, and I can tick some boxes in this app. I can delete some things and I can add things to my list, or things D. And the way it works is with HTMX and Alpine. So it looks and feels like a modern, rich front-end experience. To the uninitiated, you might think that this front-end is being built and managed with something like React or Vue or Svelte or like one of their many competitors, and it's not. This is not a single-page app. This is an HTMX-based app, and it's got some Alpine in there too. And you can see here that when I add new things to the to-do list, then we get some HTML back, and the HTML gets rendered in a useful place. So this is really cool because we can do some very nice, rich front-end things without needing to rely on a completely separate heavy framework. We just have to rely on these extra HTML attributes and whatnot. But the thing is that like testing is important, as we know, and Django's got built-in testing goodies, as we know, but it doesn't have front-end testing goodies built in. Django has no idea what hx put means. It has no idea like what to do with this response when it arrives. Like, it doesn't know how the stuff works. HTMX knows how the stuff works, and parts of this again are done with Alpine. So we can't only rely on Django's built-in unit testing. We need something more, and that something more that we're going to be using is called Playwright. So Playwright is a tool that does browser automation. So when you're interacting with Playwright, you can spin up a browser and you can interact with different elements of a page. You point it at a page, you can like click on buttons, you can wait for things to load, you can fill in forms and whatnot. And then it also has all sorts of built-in test goodies. So that's very helpful. So this might sound a lot like Selenium to those of you who've been around for a while. And Selenium is a very powerful browser automation tool, and it's great, but it's almost like low level. It gives you a lot of control, which is fantastic, but sometimes things get kind of brittle because interacting with the browser, it can be a little bit unpredictable in terms of timing. So let's take this as an example. If I add this again, then a request went to the back end, a response came back, and then that response got rendered in the right place in the screen. And that takes time. So if you're writing some Selenium code, then you end up like needing to account for those delays in different ways. So Playwright has some nice tooling around simplifying your code and making it not so brittle. And it's got some nice things around expectations or assertions and tracing things and keeping track of what your stuff is doing, and even, which is cool, generating code for you. So I'm going to go through all of that, and I'm going to show you how it plugs into Django. So here is some code. All right. So here's how we run our tests. So I've got our run server running over there, and here I'm going to run our tests. So I'm just going to say Pytest, and you can see some green dots, very anticlimactic, very boring. But there is something to notice here. The first thing I want you to notice is that we're using Pytest. So again, Django's got its own built-in unit testing stuff. It's not Pytest by default, it's something else. Now, when I created this workshop tutorial, I wanted to make sure that I was keeping things as vanilla as possible. I didn't want to add on all sorts of extra fancy stuff. I just wanted to keep the star of the show. But it's really useful to use Pytest in conjunction with Playwright because there's all sorts of useful Pytest Playwright functionality that exists in a nice package that you can download and use. If you wanted to just use plain like Django's unit testing stuff, then you'd need to build that functionality yourself, and it's a mission. So don't do that. Rather just use Pytest. Right? So that's why I'm using Pytest. Now, I've got a bunch of different tests here. I'm just going to go through this test in detail. I'm not going to go through like everything because it's going to be a little tedious. So this test is about displaying an empty list on first load. So it basically says that when we load our page for the first time, it should say nothing to see if the database is empty. So I'll just demonstrate that here real quick by deleting everything. It's like nothing to see here, ... which is fine. It does say nothing to see. All right. that's what this test is doing. So if you're new to Pytest, then it's worth knowing that Pytest is like one of the selling points of Pytest is the fact that it has like very little boilerplate. Each of your tests is just a function. It can be just a function. And you can tell it's a test because it says test at the front. So when I run Pytest, it looks for functions such as this, and then it runs them, which is great. When it's running a test, it looks at whatever like arguments you are defining there, whatever you're passing in, and it tries to figure out what these things are. So it does this thing called dependency injection. So these things are called fixtures. These are all kind of funny words, but basically when I run this test, Pytest is like, oh, you need a thing called live server. Let me go see if I know what this is, and then I'll give it to you. Oh, you also need a thing called page. Let me see if I know what this is, and I'll give it to you. Now, you can define your own fixtures. You could make your own thing called live server. You could make your own thing called, I don't know, authenticated user page, whatever. You can define these, but these ones are already defined for you. So live server is something that Pytest Django defines. It's a package that you can use. I think it's Pytest Django. And then page is something from Playwright. So this one, basically what it does is it spins up a server. It's very much like run server. So it's a lot like this, but it's at like a weird funny port, and it uses its own special test database and things like that. And then page is a Playwright thing. So this gives you a browser, and then it makes a tab in that browser, and it gives you access to that tab. So you can do things like, say, go to a specific URL. So those are our fixtures. Now, going through this test line by line, there's only 3 lines, nice and simple. So the first thing we do is we figure out what URL we want to visit. We want to visit our index page, and that is that name comes from our urls.py file, and it needs to be in relation to our live server. Like it can't be on our 8080 because if this is not running, so this usually runs at port 8000, oops. The test should still run even without that running. Like you shouldn't have to run your run server in order to run your tests. It sorts itself out. That's what that is. Then the next thing I do is I say, okay, now I've got my URL. Let's go to that URL. Let's visit it. That makes sense. So these 2 lines, like nothing too spectacular is happening. Here's where the spectacular stuff happens. There's quite a lot going on in this line, so I want to just drill into it a little bit. So here we're just saying wait for the page to say nothing to see. There should be some text somewhere that says this. First thing to notice is that we can ask Playwright to look for specific text. We can also ask Playwright to look for other things. So here we are looking for something that has the label title, and then we're filling it in with the value foo. So this is actually filling in a form, and then we're clicking on a button. And over here we're clicking on the button again. There should be here we're checking a box and we're expecting it to be checked. So you can really access any part of the page you want. Now, you'll see that there's all sorts of different ways to access different pieces of the page, like get by test ID, wait for selector. There's something about a role, I think. Yeah, get by role button, get by label. There's all sorts of different ways to do that. Remembering all of those different ways can be a little tedious, can be a little painful. There's a cheat code I'm going to show you later because Playwright can help you actually generate the code that you need. All right, so that's that. Now, what have I done? All right, cool. The next thing to notice about this line that's cool is that it says wait for selector. So remember earlier when I was talking about Selenium, like when you make a request, like if you interact with a web page, there's generally always some kind of delay before your intended response happens, before the reaction happens. So like maybe a request goes to the back end or something else. Now, Playwright is cool because it waits for that stuff to happen for you. So even in this little test, like we go to a URL, a whole lot of things need to happen. Like the page needs to load. We need to request some HTML from the back end, then render it on the front end before this nothing to see actually shows up at all. And so even in this, there should be a delay between going to the URL and seeing what we expect to see. Now, you could make those delays happen in a very explicit way. You could say like time.sleep something, and then I don't know, 10, who knows? How long does it take? I don't know. And then your test would run. If we didn't have this like wait for selector, if we just expected it to be there. You could write code like that and it would work. But the problem is that it's brittle. Because you don't really 100% know how much to sleep at any point in time. Maybe your computer's busy working on something else, and sometimes it needs to sleep a little longer than other times. Maybe you have a whole lot of interactions with the web page, and now you've got a whole lot of these sleep statements, and that makes your code very hard to read, and it can make it kind of slow. Maybe you're working with a colleague who has a really slow and terrible computer, and so they just increase all the delays so that it works on their computer too, and now it's slow on everybody's computer. So you really don't want to manage these delays explicitly yourself. It's better to let something else do it. So it's interesting because Playwright does this for you. So under the hood, what it really does is it has a sensible default, and it'll check that the selector is as it should be, and it'll keep checking until either it finds the thing or the thing doesn't, or the timeout happens. And so I'm running the tests now, and you can see that not a lot is happening. It's just chilling. It's not going to chill forever. It does have a sensible timeout, but it does take a while. I think its default is like 30 seconds, which is pretty long. There we go, we've got a failure. So when something fails because it couldn't find a thing, it generally won't say I couldn't find the thing. It'll say we had a timeout error. So that's how to interpret those timeout errors. You will get them from time to time, and that is completely normal. All right, so I'm just gonna change that back. Okay, so I've been talking about how we are automating browsers, but you haven't actually seen the browsers. So something that's really cool about Playwright is that when you run it with Pytest, it runs with certain very sensible defaults, such as, for example, run in headless mode. So that basically means it doesn't actually show you the browser. The browser is running, but it's not being rendered on your screen. This is cool because having the browser render every time you run a test can be quite a distracting experience for the programmer. But it's also cool because it means that you can put it into your continuous integration pipelines, and it just works by default. Like its defaults are set up so that it makes sense in an automated place. So if I want to change that, I can say headed, and now it'll run in headed mode. And you can see there are the browsers. It's still kind of weird. It's very fast. You can't really see what's happening. So I'm going to also say slow-mo equals 500. So now I'm saying wait half a second between every interaction with the web page. So you can see there we're adding some stuff, we're adding some more stuff, we're testing a whole lot of different things. All right, so that's quite cool. Another really useful thing is to be able to do things with a different browser. So I'm going to say -- browser Firefox. And now you can see that this looks slightly different. So I can test it with Firefox. The default was Chromium. It can also do it can also do the Apple one, which has a name that escapes me. Now notice here that there were 7 tests that ran. So now I'm going to say -- Chromium as well. So now I'm testing it headed slow-mo 500 in Firefox and Chromium. Whoa. Right. Browser. Chromium. And now we've got our 7 tests running in Firefox first. And now you'll see that there's another 7 tests running. And these are in Chromium. So it'll be 14 in total, 14 passes. So this is, again, pretty cool because you can do this in a continuous integration pipeline. Or you could you can decide to do the final tests across the other browsers just before you commit. There's all sorts of different ways to combine these. All right. Now the next thing I want to show you is this thing called show trace. So I'm going to just backspace this stuff to make it fast again. And I'm going to say show, what is it? Show, no, not show trace, but tracing on, right. Tracing equals on. Now pay attention to the left hand side here as I run this. Did you see something changed? Something jumped. Basically it made this new directory over here and it's getting filled up as we run our tests. So we ran 14 tests, there are 14 directories over here, and if I look at them you can see that there's to do tests, test to do py, so this is basically the path to this test module. Test checkbox dash Chromium. So there's a test called test checkbox and we're running it in Chromium, and then we're running it in Firefox, then we're running this one in Chromium, then we're running this one in Firefox. So it generates all of these files where we're storing a trace. I mean all of these directories where we're storing a trace. And if you look inside these, there's a zip file, each one of them, and they're horrible. You don't want to interact with them directly. But Playwright has a nice way of interacting with them. So it's got this command called show trace. I'm just going to grab that and I'm going to paste it in there because it's long. So it's Playwright show trace and then the path to the thing that you want to see. So the test I'm showing you is that when we create a to-do list item, it gets rid of the nothing to see message, and we're testing it in Chromium. So if I press enter there, cool, it opens up this thing, and I'm just going to make it a bit bigger. Can I make it bigger? Not really. All right, so there's a lot happening here. Let me move my giant head out of the way. All right. Cool, there's a lot happening here. The first thing you can see is that there's a timeline of everything that happened, and you can see in the little hover text what was happening at that point. Here we've got everything is open. You can see that our localhost port is like very weird. Localhost 56967, weird, not 8000. You can see that now I'm like clicking on get by label. So you can see in the hover text exactly what we're doing at different points in time, and you can look at it on the side here as well, and you can see like we opened up a new page and then we went to this URL and it took some time. It took 183 milliseconds, and then we clicked on a thing and it looked like that, and then we filled it in, and then we clicked on a button, and then that was our life. You can look at it on this side as well, like you can see exactly when every single request went off. You can look at, we called this action add to new to do. So this is our own URL, our own endpoint that we called, and you can take a look at what was passed to it, what was the request, is there anything here? Yeah, so there's the request body, title equals foo, we were filling in a form. You can look at the response, you can look at the response body, and that's some HTML. So you can really get a good picture of everything that's happening over time. If there are warnings, you'll see those as well. So this is very, very helpful if you want to see when things are breaking. Here we just use like tracing equals on, that command over there, and that's great because it keeps track of absolutely everything, but a lot of the time you don't want to keep track of absolutely everything. A lot of the time you just want to keep a trace on failure, and that's an option as well. So that's very helpful. Now, you'll notice that I am running things in VS Code. Maybe you'll notice that. So you have full access to VS Code's debugging goodies as you do stuff in your tests here. So if you do have something that's failing in a weird way, you can drop into a debugger. I'm going to show you, I'm not going to show you the VS Code stuff. I'm going to show you breakpoint. So let's say this test is breaking for some reason, or you're just curious about what this URL is or something like that. I can do this sort of thing where I just throw in a breakpoint. So a breakpoint is just like a perfectly normal Python thing to do. It's got its own debugger built in, and I freaking love it. It has saved my life. Breakpoint is great as well because it works on remote computers and stuff like that. Anyway, so I've run Pytest, and there's a breakpoint, and our code has stopped at that breakpoint. And if I say L over here, then you can see, cool, I'm about to be on this line. We just executed the breakpoint line. I'm going to see what the URL is. 48099 is the port, and then I can say next, then I can say next, and I can say continue. So I can make use of that to interact with the codes in different ways, interact with the tests in different ways. And I personally like to do that a lot. So actually, let me control Z that, save. Something that I'll often do is I'll say Pytest and then headed with a breakpoint. And then you can see here, let me just do this so you can see everything. F11, All right. Let's see. All right, sweet. So we're here, and you can see that I'm about to execute this command, go to URL, and this is the browser that we've got. That's our page. So if I say next here, then that happens. Now I can see what's the next thing that we're going to do. So we're going to wait for the selector nothing to see to show up. I can say next, and then it's working. I can say continue. So this is it's a very handy thing to do. Yes, so that is that. Whoa, where are we? There we are. All right. So I've shown you quite a lot already. Now, another thing that I want to show you is the code gen. So the code gen is something I alluded to earlier on. It writes code for you, but not in a spooky way, in a very explicit way. And I will show you how to do that. So let's go here quickly. Let's say, for example, you have an application that's running, and somebody has reported a bug. So this application actually has a bug. I kind of left it there on purpose. I'm going to close that. Let's see the bug. Check this out. Let's say I've got 3 things to add to our to-do list. 1, 2, and 3. 1, 2, 3. Oh, damn. Look at that. It says 1, 2. That says 1, 2, 3. Ideally, when I add something to the list, this form should be cleared. So this isn't technically a bug, but it's a usability bug. Like if I was using this application as a user, I would not be happy with this, because you have to remember to backspace every time, and of course it's backspace automatically. So if you have a bug in your tests, in your code, in your front-end code, then it's really nice to fix that bug in a TDD fashion, in a test-driven development fashion. So what I mean by that is you write a test that proves that the bug exists. It proves that this thing is broken, and then the test will fail because your thing is broken, and then you go and you write the code to fix the test after that. So you fix the bug, and then the test passes forever. So I'm going to use this command, playwright code gen, and it's not 8181, it's 8000. All right. So actually, if I kill this and I run this, it breaks. It's like this thing isn't running. So when you use code gen, it's not going to spin up its own server. You point it at a URL and it'll go there. So you can actually point it at some live website somewhere if you wanted to, and write some code about that. And that's also a very helpful thing, because web scraping is a thing, and it would be nice to automatically write the code that you want, or interrogate the websites that you're interacting with. In any case, I've got run server running over here, so now it's running at 8000, and I'm going to run that. And Playwright opened this up, and you can see that there's all sorts of weird things happening here, and it also opened this up in a funny place. So it opened up 2 windows. Right. Now, as I interact with this, you'll see that lines of code happen, they get executed. I can tick things. Oops, let me open that a bit more. It should be responsive, but it's not. I can delete things. I can add stuff, and that works. So the test that we actually want to write in this case is that when I go here and I add something, we want to assert that after we click add, after we submit the form, this thing is empty. So if you take a look at the top here, there's a bunch of different things. Like if you hover over these, it'll tell you what they are. Pick a locator, assert visibility, assert text, and assert value. So we're going to use assert value. We want to assert that the value of this input is empty. So here, it's you can see the code here. It says get by label title to have value something. All right, so I'm going to copy this code. I'm just going to grab the whole lot. Make sure you copy it before you start closing things, because everything closes all at once. So do that. I'm going to write a new test. I'm going to say def test add item form clears after mission. All right, so that's a good name of a test. I'm going to just paste all of that stuff in. Now there's a lot of junk code in here. There's a lot of stuff that we don't actually need. And if I go here, I probably want the same things here. So the live server and the page, I'm just going to put those there. Oh, and I'm going to spell that properly because that's better. So I don't need this anymore. because I've got the page, and then go to URL blah blah blah. We don't want that, because remember our URL is something that we need to generate based on our live server fixture. So I'm going to do this, reverse URL live server, blah blah blah, put that in there. Now I don't need a lot of this stuff. I'm just going to take title, click title. Okay, we got that. All right, so here we got, like, we click on our title input, we fill in something, we click add, and then here it says expect page by label blah 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 to have value something. We actually want it to have value blank, and for some reason there's a semicolon. Just get rid of that, because who needs them really? All right, cool. That's our test written. And now when I run Pytest, you'll see that that last test is going to fail. There are now 8 tests. That last one, it's going to have that that default waiting behavior. It didn't wait for that long, and it failed. So okay, here it's just like assertion error in this case, not a timeout error. Cool. So now what we can do is we can change our front-end code so that it does actually clear between submissions, and then that will work. All right. So that's basically everything that I wanted to show you. There's one more thing, and this sort of serves as a summary of what I've shown you so far, but also as a, like, you will use this. If I say pytest -- help, then it'll give me some fantastic test, like help text. There's quite a lot of it, and if I scroll forever, and there we go. There's a Playwright section. So we have used most of these options here. I'm just going to go through them again very briefly so that you know what they mean. So we spoke about browser earlier. So we dealt with Chromium and Firefox. WebKit is the Apple one. So that's cool. And it's a browser engine. It's not the actual browser. So we're running Chromium, not Chrome. And we're actually running the thing underneath Firefox, not exactly Firefox. So there are some, like if you were to point Playwright at certain websites, it would pick up you're using Chromium, and it would kind of freak out a little bit perhaps about like is this an automated process? So just be aware of that. It's good for testing. It's not always good for some other things. Then there's headed mode, which we spoke about. So by default, it is headless. Browser channel, that's kind of what version of the browser to use. Slow-mo slows it down so you can see what's happening. So this I usually use in conjunction with headed if I want to see what's happening. Device. So you can, for example, simulate an Android device. Not something I've done, but it is a doable thing. Output. So this tells you where the traces are going to be stored. So remember earlier, a new directory got created, and then a whole lot of things got put in that directory. So you can control that over here. Tracing, we spoke about as well. So I showed you tracing on. By default, it is off. And then you can also say retain the trace only if the test failed. You can even take a video of your test, so that's quite useful. You can slow things down and add a video. You can take some screenshots, and you can make them full screen. So that's all very helpful stuff. And that concludes the demonstration.